All right. Welcome, everybody. Welcome to our Surfliner Sprint Review Spring 2026, Sprint 1. For this sprint, we're focused on delivering a connected system by end of work cycle and unblocking production data migrations. The two milestones that are driving this cycle are discovery integration and discovery development, while also advancing key foundational work. On the integration side, we're focused on enabling publishing and unpublishing from Comet to the discovery prototype and positioning ourselves for the upcoming UCSD discovery development and integration work. In parallel, we're exploring how to push front-end development forward on the discovery experience itself. We're also moving the needle on an interim solution for controlled values, which involves architectural, infrastructure, and design work this cycle, followed by implementation into both Comet and Golden Gate. And finally, we're continuing to invest in Comet ingest improvements and reliability, keeping our core system stable and performant as the broader ecosystem grows. With that said, I would like to hand it over to David and to Margaret to talk about discovery integration.
Yeah, so let me find something I can demo because demoing is always more fun. Do you mind if I share my screen, Gabriella?
Absolutely.
All right. So hopefully this is a good size for most folks. I'm going to go into one of these objects. This has a few different images in it. I'm going to publish that to, well, first let's show that it's not there. Oh, so here's our discovery prototype. I'm going to search for test, and you'll see it has a test image, but not this one. So let's go ahead and publish that to Golden Gate. Yes, I'm sure. All right. Give it a second. And there it is. So that's working. I can also unpublish it. Unpublish from Golden Gate. Okay. And now if I try to load this again, it's not finding it, which is appropriate. But now if I publish it or republish it and run my search, here it is. Um, and we also made some back-end improvements that are we don't have the front end quite there to demonstrate yet, but we can now download all of these images via the API. So I'm just gonna go into the API here, which is going to be a little bit let's see, going to be a little bit cryptic, but see how it works. So we've got here's the oop, that's not the right ID, 299. Okay. 299. So here is the metadata for the object. It's got some file sets in it, which I can get to by hitting the members link, which is also down there in the API response. Um, let's look at one of these file sets. We'll look at this first one. Um, it's got a couple of files in it, and I'm going to download the first file by going to this link. And this is actually going to go it's going to redirect to a um, S3 pre-signed URL, um, and there it is. And you can't see it because it's not sharing that window, but it did in fact download. So in the next sprint, we'll be working on adding the front end support for that. I'm going to stop sharing now. Gabriella, you could share the agenda again if you want. Um, So another piece that I'm not going to bother to demo, we decided we had some really good discussions about what we wanted our URLs to look like and how we want to use arcs, and settled on the standard URL for an object in Golden Gate being just the arc. So we have support for that in the API. If there is an arc, on an object, that's now the preferred URL for it. If you try to get it by the database ID, it'll redirect you. If you ask for something by ARC, you'll get it. And we did some work on integrating that into the UI, but there's some additional changes that we need to make, which Elisa can talk a little bit about. But that's on the way, which means that we can now start working on things for UCSB, like handling redirects from our old URL patterns to the new URLs. So that's getting us much closer to production ready there. Margaret, do you want to talk about the SuperSkunk API stuff?
Yeah, so in between work cycles, we did some analysis, and folks were changing their configurations for the API service, which we call SuperSkunk, which is how data gets from Comet into Golden Gate. And we had some difficulties because when we were working on getting the IIIF viewer working and images and all of that, we had a couple of different approaches that we tried. And there were a bunch of API endpoints just kind of hanging around that we weren't using anymore. But it wasn't obvious from looking at the code. So we thought that SuperSkunk had certain requirements because there were these API endpoints that needed it. And it didn't actually have those requirements because they were still hanging around. So we took the opportunity in this sprint to just get rid of everything that we weren't using, simplify the API quite a bit. And that should make it easier for us to do those kinds of analyses and understand what we actually need to support there, instead of having a bunch of API that we're not actually using that we think we need to support. So that was that ticket. Vivian did a lot of that work and did a good job. So kudos there.
Thanks, David and Margaret. Let's skip down to discovery development. This is Elisa and David.
Yeah, so I can get us kicked off. So this sprint we worked on really what it's going to take to get production ready. There was a lot of discussion about what that would look like and then turning those discussions into tickets. There was also some refactoring that was started that allows us to respond to the API that David was showing. And next up is also better responding to the arcs as they deliver the objects now. And so in this upcoming sprint, we will have quite a lot of fun, I think, in the front end because we now have an API that supports and drives a lot of the dynamic ability of that discovery. David T., is there stuff you would like to add for the development you did?
No, I think you covered it well. I mean, if I had anything to add, it would just be that on the UCSD side, I was able to go from a look and feel point of it, like initially resembling ADR Lite to something that more resembles our local design intent.
Thank you, Elisa and David Trujillo. Let's jump down to Margaret, who'll tell us about interim solutions for controlled values.
Yeah, so last work cycle, we came up with a plan, which was to just check in some CSVs and TSVs that have the controlled values that we need in the short term into the repository. And then we would transition that over to Lurk once we had Lurk up and running. So in between work cycles and at the beginning of this sprint, I did some work to kind of architect and implement how the back end piece of that would work in terms of the underlying technologies. And I think we came up with a pretty good solution where it will be pretty seamless and won't require a lot or maybe any work in Comet or SuperSkunk to make that transition once it eventually comes. And we can use the CSVs and TSVs now, and then once Lark is up and running, it'll be like a schema change in order to switch it over to pulling from Lark. And everything else should follow pretty easily. So I'm pretty happy with how that turned out. And then for the past week or so, we've been trying to get Comet using this. Getting Comet just like actually using it in a very simple sense is very easy. But if we were to just turn it on in Comet, we would kind of have a problem where if you loaded the edit page for an object and it would render a drop down of thousands of different options because that's how many controlled values there are, and that's how it does it. So we're working on replacing that massive dropdown with a type ahead selector where you type a couple letters and then it does a search and then it just pulls up the things that start with those letters. Um, and that's been a little difficult due to how things in Hyrax are architected, so it's taken us some time to get it done. But I think we're pretty close on it, so I'm feel like we can probably get that done early in the next sprint. So that's where we're at with that. And then we'll also need to do it in Golden Gate, but that work is still forthcoming as well.
That's exciting. Thanks, Margaret. Let's get down to number 4, Comet Improvements of Reliability by David Moles, Michael, and Matt.
Yeah. So the first thing is a small thing, which is just that now if a collection has an arc, that will now be displayed, as we can see right here. Then so uh, we were running into some issues with characterizing certain TIFF files with having with the analysis that we do of what kind of file is this and other technical information about the file. And we use a tool called FITS for this, which is pretty much what everybody uses, but it's kind of a wrapper around a bunch of other tools. And we found that one of the tools that it was using, not sort of one of the primary ones, but one of the secondary ones was very out of date and was mistakenly identifying some images as Excel spreadsheets, and that was causing various problems. So we had already been talking for a while with preservation folks about wanting to be able to customize the configuration of the FITS tool. So we're not set up yet to have, like, say, different configurations per campus, but we are now using our own FITS configuration file instead of just using the one that ships with it out of the box. So that's configured now to disable that one obsolete tool, which cleared up that particular problem, um, and should position us well to customize that further in the future and do other things around recording important preservation metadata around file characterization. So, yeah.
Great, and I think I'm up next to talk a little about some thumbnail generation and reliability investigations as it relates to PDFs and pyramidal TIFF. Both are a little bit different, but we sort of first uncovered this on the UCSD infrastructure after testing a bunch of imports and finding some small number of missing thumbnails. What was interesting about this was that number would be slightly different run to run, and even for the same files, it's a little bit different. So even if you run the same importer repeatedly, it's not the same file that will error between runs. And what we uncovered was after we patched it with one bug fix, we think we've actually exposed a race condition, which is pretty tricky. And it's also impacting sort of pyramidal TIFFs. Pyramidal TIFFs have an additional causal factor there, which is they require using some of the current tools that we're using, ImageMagick, to create the thumbnails, a lot of memory in the Kubernetes cluster to sort of deflate, spill that pixel cache to disk, and then actually generate that. And so the two of those are failing for slightly different reasons, but we think we've got at least some decent data to bring back to the team and share, and then also talk about some alternatives. We've talked, I think, briefly about at some point considering where we'd like derivatives to be created, if that's actually in Comet proper or adjacent to. And so I think we'll be sort of thinking about very pragmatically how much engineering time we want to dedicate to this particular issue and what the implications would be even of any particular solution. I think really huge shout out to both Longshu and Matt for, I think, probably one of the deepest dives I've been a part of. I learned a lot on that, but also like a very, very tricky layered bug to try and get behind. And I think up next, I'm going to talk briefly about some large file size ingests. In our collection, we have some fairly large objects. I think we successfully were able to ingest about 2 terabyte file. And also in that, we're also investigating some leaked temp files. And what we generally found is with any one particular file that's ingested, we have either 2 to 3x that file size that's not cleaned up as leaked files. which you can imagine for a 2 terabyte file is actually quite a bit of space. The edge case here is really easy to detect. I think, running serially for something like that on an edge case is one thing. I think that where this gets challenging is for large runs of files that are in a middling size, so like much larger than, in the gigabyte range, subsequently are filling up the node disk space and will cause some issues. So we're also kind of rethinking how and when to prioritize a fix around that. Probably first, though, I think, and as we'll see next year, is going to be definitely the thumbnail issues and discussions there. I think after that, Gabrielle, I'll maybe just invite Matt if you'd like to say anything, and if not, then we'll go on to what's next there for you.
I think that covers it. We are good. So the hydroderivatives gem that Comet uses in a recent version does add support for using VIPs for creating image derivatives. So we're in the middle of running some tests on that to see if it will make the situation any better. But I think Michael's point about, probably needing to zoom out and think about how much of this we really should be leaning on the job framework for is still going to be a thing we want to do, but it's possible that using VIPs instead of ImageMagick will make at least some of the issues we've been running into less bad.
Thanks, Matt.
So David, Moles, and Michael, do you want to take us into the next section on what's next? What's coming up?
Yeah, sure. So on the discovery integration side, we have the basic search API working. We have basic APIs for getting metadata back for different kinds of objects, but we want to add some refinements. So we've added a visibility flag to the metadata a couple sprints back. We want to make Golden Gate respect that. We'll have to do some let's figure out how to sequence that, like which of the how much of that functionality we need when, because we probably can't deliver it all at once, but we can at least make sure that restricted content isn't showing up. And we want to make some improvements to search to match kind of the baseline of the stuff we already have. We have exact matching of specific properties or facets now for the facet display, but we'd also like to be able to do a keyword search there, so you can say, just search for somebody's last name within the creator field, that kind of thing. We don't have searching or filtering on dates yet, so we want to implement that, which is always fun because dates in cultural heritage metadata are come in a lot of different flavors, but we're gonna work on that. Right now we just have kind of a default relevance-based order that everything comes back in, and we want to add some support for sorting on those things. Something that we've been running into for a while is that it's kind of difficult for the front-end developers to work locally without realistic test data. And getting realistic test data is not straightforward because, of course, um, ideally we would want all the metadata and all the objects that have been loaded into Comet QA or production, and that's a lot of stuff. So it's not something that we can easily just spin up on a developer's workstation, but we've had some discussions around things we can do about that, and we're hoping to improve that. The other piece is that for local development, for a long time, we've been using a test schema that is sort of it's not really the schema that either campus is using. It's kind of lowest common denominator, just enough to do automated tests, but it leads to some weird behaviors when you're trying to test with data that you've extracted from one of the running sites. So we want to make sure that we have support for front end development that against a Comet that is using either the UCSB or UCSD schemas, or like we currently have in QA, using both schemas at once. So that will hopefully make things a lot smoother for the front end team and make for a lot less a lot fewer issues where you're not sure if the problem is in your code or in the data or somewhere in between. Yeah. Elisa, David T, do you want to talk about the front end stuff?
So similarly, that's work is being done to look at the API. We're going through the code, making sure that those web components are displaying information correctly. Like David explained, we were having some issues with the test data, so that the representation of what it'll actually be in our QA environment is not quite yet aligned. So we made a lot of progress there. So we're going to now be able to implement that progress and what that looks like to help better and really grease the wheels for getting everything built out as it will be delivered in production.
Michael, do you want to jump in for comment? What's
Sure.
up?
Sure. I think we're going to be continuing and finishing up our controlled value support for that interim solution and sort of enabling some things for each campus. I think, as I mentioned earlier, we're going to continue sort of our alternate pathways and a good sort of first principles engineering look at those thumbnails and leaked temp files to see how we're going to prioritize those given the time we have. And then also probably weighing sending some metadata to EasyID and possibly the DOI support, which we've had scheduled.
Excellent. This looks like it was a very, very lucrative sprint. So thanks to everyone for the hard work completed.
Yes, thank you.
Yeah, it's excellent. It really is. Do you want to entertain any questions? And if no questions now, we can ask for you to jump in after I stop recording. But for now, does anybody have questions? Okay, with that said, I'm going to stop recording and then you can feel free to ask all the questions